spray nozzle selection for gas scrubbing applications. Now this is a vast topic and this is only a very quick overview. I'm going to go through various different types of scrubber type and then make some suggestions on what spray characteristics and what spray nozzles might be useful for those scrubbers. Firstly, let's look at wet scrubbers. Now wet scrubbers, the basic operating principle here is we're passing a gas flow through a atomized spray. That atomized spray interacts with the gas flow and knocks out contaminants. Those contaminants can be the liquid contaminants, gaseous contaminants, or even particulates within the gas flow. So the basic operating principle is passing it through an atomized spray, and what we want here is to generate a large surface area of liquid for the gas to interact with. The bigger the surface area, the more chance of interaction and the better the scrubber will perform. So drop size is clearly very important here. The smaller the drop size, the bigger the surface area for any given volume of liquid sprayed. So on the face of it, it might seem like the smaller the drop size, the better the scrubber will perform. And that's true to a certain extent, but there are some serious limitations on this. We also need to ensure that the spray reaches over the entire spread of the gas flow. Not a lot of point just spraying the reagent into one part of the gas flow, it has to reach to the sides. But we also need to ensure that it doesn't hit the sides too much, because as soon as the liquid hits the sides, it destroys the spray, destroys all that lovely surface area, and therefore we're to the detriment of the actual effectiveness of the scrubber. So we need to get good drop size, or a small drop size, and we need to get good coverage, but not too much coverage so that it's hitting the walls of the scrubber. These factors can be in tension with each other. A very, very fine mist will be great surface area, but will struggle to penetrate through a fast moving gas flow. And indeed, it may get entrained within the gas flow very, very quickly. And so we're not going to get that coverage. So we're going to have streams of big parts of the gas flow that are simply not going to come into contact with any of the reagent, and so are going to be completely untreated. We need to get a balance here between good drop size and then having bigger drops in there so we can carry that spray to where it actually needs to go. And then of course we need to factor in the spray angle of the nozzle as well, because big spray angles get better coverage, but if we're getting too much coverage, we're getting a lot of that liquid on the walls of the chamber, and therefore we're destroying that drop size. So there's a tension here between good drop size and surface area and having the sufficient drop size to penetrate the gas flow, and then having the right spray angles to ensure that we're not getting too much on the walls but getting complete coverage of the gas stream. Choice of spray nozzles for these absorber spray, these wet scrubbers, can be something like our TF spiral nozzles. Now these have a good drop size for any given pressure, so they give good atomization, and they also come in a wide variety of spray angles. So they can move from anything from a 60-degree spray angle all the way up to a 170-degree spray angle. So we can start to get that really, really good coverage. And there's a lot of iterations between that 60 and 170, so we can get it optimized so we're getting that lovely coverage without hitting the walls too much, we talked about. For narrow spray chambers, where we need to basically inject the spray in a narrow gas stream, perhaps we're looking at something like a Venturi scrubber with a narrow throat to aid with the atomization process. Then we might want to look at something like our NCK nozzles, our injector nozzles, and these can come down to 15 or 20 degree spray angles, very narrow spray angles, much lower than the TF nozzles and spiral nozzles. Now we sacrifice quite a lot of drop size in this, they won't atomize as well, but we get that narrow spray angle, and that can be very important in certain scrubber designs, so they might be a good choice as well. So moving on to packed bed scrubbers. Now these are still wet scrubbers, but they generate the necessary surface area in a fundamentally different way. We're not relying on the atomization of the liquid by the spray nozzle to generate that surface area for a reaction. Instead, what we're looking at is a packed bed, a media bed full of small, very geometrically complex shapes that the liquid is sprayed onto the top of, it trickles through, and that complex geometry creates the surface area for the reaction to occur as the gas passes up through that media. So we're not worried about drop size here, we're not worried about atomization. What we are worried about is getting the fluid over the top of that bed so it trickles down nice and evenly throughout the entire bed, and we get that good interaction. With these types of scrubber, again, TF nozzles are a really, really good choice because we can get up to that 170 degree spray angle there. And this allows us to get the nozzles quite close to the top of the bed, or closer to the top of the bed than if we were having narrow angle spray nozzles. What this means we can do is we actually can keep that headspace smaller, and so reduce the profile of the overall scrubber, and this can make the scrubber more cost effective and much more efficient. So they're a good nozzle choice there. Wide variety of spray angles, very wide spray angles, and a wide variety of flow rates are available. We sell a lot of these into using these types of scrubber. So looking at dry scrubbers, and this is mainly for quench or pre-quench systems, because in dry scrubbers we're not actually spraying a reagent to react with the gas, we're using a powder or something like that to knock the contaminants out, but we will be using spray nozzles in most cases to quench that gas flow, to make it cooler, which would assist the scrubbing process because it slows down the gas and prevents hot gases from damaging the scrubbing system. So with quench systems, again, drop size is king here. What we really want to do is we want to increase the surface area of the quenching fluid, which is normally water, and that increased surface area increases heat transfer, and so we get very rapid evaporation of the liquid into the gas stream, and that's what produces the cooling. Most of the cooling is produced by that high latent heat of vaporization of water, and so small amounts of water that are fully vaporized from water into steam into the gas flow produce quite big amounts of cooling. Now, nozzle selection here is all really about getting that drop size down so we can get that rapid heat transfer. So for small gas flow, we might want to look at something like our PJ or L misting nozzles. These are low flow nozzles that produce very, very small drop sizes. For larger gas flows or variable gas flows, we might want to look at something like our spiral air atomizing nozzle, and this assumes that we can tolerate putting some air into the gas flow. Or if we've got very variable gas flows, so we want variable cooling, we want to make sure that the drop size remains consistent with variable flow rates of water going in there for different cooling loads, then we might want to look at something like our spillback nozzles, which are designed for precisely that purpose. So they can produce consistent drop size across a variety of different flow rates. So those are some nozzle selections for gas quench systems for dry scrubbers. So that's a very, very quick overview of this last topic. There's a lot more to this. This is bread and butter business for us at Spray Nozzle People. We advise engineering companies around the world on nozzle selection for a huge range of different gas scrubbers. There's a lot of nuances and technicalities here that we can't cover in this video, but that's a very quick overview. If you have any more questions, please get in contact with one of our sales engineers, and we're more than happy to talk you through nozzle selection for your gas scrubbing application.